Alright, so I've decided to do one of CXC's infamous tables. It comes all of the time. Sometimes they break it apart, sometimes they bring it as a whole, but children tend to never know how to answer these questions. So here we go. So a student carries out the following test on a solid Q and makes the observations recorded in the table below. Complete table to show all possible inferences and write ionic equations where required. Now, so it says here, a small amount of Q is heated in a dry test tube. And the observations are the things you see. You don't write equations for observations. They're the things you see. What happens, right? Don't infer in an observation. You just say what you see. So it says here, a brown gas evolves which turns moist litmus paper red, right? Moist litmus paper red. Now, that means that the gas that was evolved is acidic. And there are two possible things that you can infer about this. You could infer that it was either due to the presence of bromide ions or nitrate ions being present, right? And then you could say possibly, you could write possibly bromine gas was given off or nitrogen dioxide gas. Alright, so either one is fine. Then it says another gas evolves which rekindles a glowing splint. This is definitely the test to prove that oxygen is being given off because oxygen relates a glowing splint, whereas hydrogen um, extinguishes a, a splint with a pop, right? A lighted splint with a pop. So you know that oxygen gas is present, O2 is present. No, it says no. A portion of Q is dissolved in approximately 10 centimeters cubed of deionized water. The resulting solution is divided into three portions for test 2 through 4. So, to one portion of solution Q from above, a aqueous sodium hydroxide is added dropwise until it is in excess. A wet precipitate is formed, right? When a wet precipitate is formed, it's possible that it's aluminum ions, um, what else? Zinc ions or lead ions are present, right? And if the precipitate is solid in excess sodium hydroxide, it therefore eliminates this and this because those are insoluble in excess, right? So you therefore know that lead ions are present. So now we have another test to see if what we found here is true. So it says to another portion of Q from above, aqueous ammonia is added dropwise until in excess. A wet precipitate is formed, and basically it could either have an aluminum, because remember it's not the same test tube you're using from here. This is test tube 2, right? So it could be aluminum, zinc, or lead present. And therefore, if we know this, we can test it again by adding more ammonia, which is what they did, and it showed that it was insoluble in excess ammonia. These two are soluble in excess ammonia, whereas Pb2 plus is not. So we have proven that lead is the definite cation present within the solution of Q. So to another portion of Q from above, aqueous potassium iodide is added. And this is a definite test for lead, right? So we say if it turns yellow, therefore you have lead ions being present. And I forgot to write down, but on the 6th paper, they asked to write an ionic equation. So ionic equation will be such that you have Pb2 plus the iodide ions to give lead, the precipitate of lead iodide, a 2 in front here, aqueous, and this will be solid. And that's basically a wrap. Hope that helps.